Hello, everybody. My name is David Soldani, and I'd like to thank you so much for having me at the Vietnam Information Security Day 2020. My speech is on 5G security challenges and responses. I've been in the ICT sector for more than 25 years and more than 10 years at Huawei, and I'm currently serving as the CSO within the Huawei Asia Pacific region. I've organized the presentation in three parts. We first go through the most important 5G security requirements. I will then introduce you the 5G security standards, and the last part of the presentation is about 5G security deployment. Now, starting with the industry requirements, the first requirements are on availability, and they are from the vertical sectors. This is because 5G is now meant to provide connectivity not only to smartphones, but especially to robotic platforms, vehicles of any kind. And any failure in connectivity may here really impact the productivity and at the same time may cost human lives. The other set of requirements are from the telecom service providers, and here we have four main key topics. The first is about the deployment of the multi-access edge computing platform. Then we have concern on network slicing. Slicing is about creating a virtual network end-to-end, so from the mobile to the core network. And here the major concern are on the slicing isolation, so the isolation between slices as well as the accessibility to slices and whether the information through the slices could be encrypted. Other concerns are on the massive connectivity. As we know, 5G will provide connectivity to more than 1 million devices per square kilometer, and therefore there are concerns on massive storms of signaling, as well as denial of service attacks on the user plane. We then have demand for a security management platform, which has to introduce a large degree of automations, especially should support an automatic patch management, situational awareness, capability, security orchestration, automation response tools, as well as AI-driven security capabilities. The third requirement, extremely important, is for the industry that are now requesting to have a globally trusted and mutually recognized security assurance scheme. The reason is because the current global security evaluation schema do not apply well to the mobile communication system. Here you have a list of reasons why they're not the appropriate mechanisms to have in place. Therefore, we are now discussing to broadly adopt the network equipment security assurance scheme from GSMA, which is practically a joint initiative between the GSMA and 3GPP. So on the one hand, we have an evaluation methodology from GSMA. On the other hand, we have the integration equipment test specification from 3GPP, which will lead then to an appropriate security evaluation scheme for the mobile system. Looking at the standards now, I'd like to introduce you the 5G standard roadmap first. So the first release of 5G, release 15, was finalized 5 years back. We now have commercial products available that was centered on enhancing the mobile broadband experience. Then phase 2 of release 16, which has been just finalized, it enhances the NDB, but also introduces a complete set of ultra reliable latency communication service features. And the two releases basically fully meet the requirements of ITU. Then we will have a release 17, which further enhances the MEB URLC, but in particular will address the challenges of meeting requirements for the support of massive machine tablet communications. And I'm here thinking of a consumer type of IoT, because the industrial IoT, it is the foundation of the release 15. Then from release 18 onwards, we will have a a series of technical specification meeting a new set of use case categories, and in particular, we will assist the development and standardization of 6G from, say, 2020 onwards, and the system is expected to be finalized by 2030. Now, specifically looking at the 5G security standards, what we have is that the release 15 defines the security infrastructure. And in addition to this, it supports the fundamental mechanisms for security assurance. And those are security assurance test cases and requirements for the evaluation of core network function as well as the base station. Practically, the release 15, what does enhances the 4G security, and here you have a few examples of what has been introduced. So the first, we have privacy preservation, due to the fact now that the user IMSI is encrypted and it was sent in clear earlier. Then we have integrity protection across the air interface for better interface security, but also we have flexibility introducing subscriber level policy so that we have a thin granularity of security deployment end to end. We also have a unified way of authenticating the end user with the introduction of the 5G core. It is practically a convergent solution. So that means providing a seamless type of access to the end users, whether it is he or she uses fixed access or wireless access. And then we have the introduction of the security edge protection proxy, which allows the encryption between the visiting and the home public land mobile network. What the release 16 does in practice, it further enhances the security assurance schema. In particular, I'm thinking of the evaluation of the network data analytics function into working function, that is for the converged network, and the security assurance for service communication proxy. It also introduces other enhancement at architecture level with the 5G convergence, fixed and mobile convergence security, and enhances also the security functionality for the vertical sectors. And in particular, we have security mechanisms for network slicing, authentication, and key management for applications on top of 5G, such as the cellular IoT, security for 5G vehicle-to-X communication, security mechanisms for the industrial IoT, MEC introduction, and also security mechanism for the support of drones or in general unmanned area vehicles. What the release 17 will do, will further enhance those basic functionalities, and in particular will take forward the user plane integrity protection, authentication enhancement in the 5G system, and in particular will enhance the 5G security against the base station, which in the case false elements are introduced in the system. So now coming back to the GSMA NAS, what is all about? And so the NAS, it is a standardized cyber security assessment mechanism. It is jointly defined by the GSMA and 3GPP, which are practically the industry leading standards development organization. And the NAS defines two schemas. So the first scheme is about the security requirements and assessment framework for the secure product development, product lifecycle processes. The second looks into the security evaluation for the network equipment using the 3GPP defined requirements and test cases, which means practice to comply with the 3GPP security assurance specifications. It is a scheme truly widely adopted by both the private and public sector. For example, we have agencies adopting it in the Europe, ENISA, the BSI in Germany, ANSI in France. And we also have carriers mandating compliances to the NSAS if you want to deploy those particular elements in their networks. Ericsson, Nokia, and Huawei openly support the NSAS as a unified 5G cybersecurity certification foundation. And now we basically have available since October last year, the NSAS 1.0, and the target is to have this scheme adopted by the government regulators so that we can achieve a certification framework and approval of cybersecurity for the mobile network equipment. And as we speak, the GSMA has announced that the world-leading mobile network equipment vendors, namely Ericsson, Nokia, Huawei, and ZTE, have successfully completed an assessment of their product development and lifecycle management processes using the GSMA and NSAS. In particular, Huawei has passed 2 tests. So we have passed the test related to the base station, but also the 5G core network product lines assessment. So the scheme release 1.0 complies with the basic requirements within the EU Cybersecurity Act, and it will be further enhanced, expanded by the end of this year, and the target is to achieve a full compliances with all requirements within the European Cybersecurity Act. Of course, adopting the best industry practices towards cybersecurity, risk mitigation, and transparency. If you look at the Huawei contribution to NSAS and in general to the 2GPP security specifications, we have that a result coming out from the report recently published by the Strategic Analytics that proves that Huawei is the clear leader in terms of contribution to the complete end-to-end 5G standard specification. And you may see here more than 32,000 papers were submitted since the release 15 started to May 2020 this year. And our contribution and participation goes well beyond that. We hold the chairmanship for the 2GPP TSG service and system aspect, which include all 5G security aspects. And we also are, Huawei is also rapporteur of a number of study items as well as technical specifications, especially for the release 16 and 17. So overall, I could say that Huawei has submitted more than 1,847 proposals on 5G security, and more than 45% of those were accepted in the standard. Really a clear leader in terms of accepted contribution. Now, about the security deployment, I would like to start from a review of the 5G threats and challenges. What I can say here that the threats and challenges are pretty much the same as for 4G, so all earlier system and generation. We do have, however, the introduction of new logical functions and elements such as the 5G core network, which is based completely on the cloud platform and virtualization. We have the end-to-end concept of network slicing, and we have from day one the adoption introduction of the MAC. The MAC is not a 2GPP element, but it interfaces to the 5G system through a user plane function of the core network, which is distributed at the edge. So we see from here that a number of potential threats are identified, but they are correspondingly mitigated either by supporting the 3GPP technical specification on security, or simply adding proprietary mechanism for security deployment end-to-end. Also remarkably is that the radio access network remains completely separated from the core network. So domain by domain, it is easy as it was earlier to deal with the specific net domain. Overall, I could say that the 5G security requires the collaborations in terms of standard devices and deployment of all industry parties, and all industry parties need to take their own security responsibility. Here you have an example of the different roles for the 5 main key stakeholders. So the vendors are expected to develop the security products and the features through integrated security processes to ensure the device security and reduce vulnerability. What we are expecting from them are quality, trustworthy products, so that network resilient can be built. Operators are the main responsible of 5G security deployment, and they must build a secure and resilient network and implement defense in-depth security and secure them to ensure the network and the end user data security. Then on top of it, we have the service providers and the end user, I would say, of the 5G services. And here, what we need to have in place are these mechanisms and technology to ensure the confidentiality and integrity of information end-to-end. And here I'm thinking an appropriate implementation of encryption and hash function for integrity protection. Then we have the standard organization that they must define security requirements and test cases to ensure device and protocol security. And then importantly, we have the government, regulators, and agency that need to formulate the appropriate rule regulations so that the industry properly implement end-to-end the 5G security with constant supervision. What Huawei does to meet those fundamental requirements, Huawei has a defense in-depth approach augmented by zero trust model. And what does it mean in practice? That is illustrated on this figure. So here we have the end-to-end 5G system, which goes from a variety of different kind of devices. We have the access network, we have the backhaul, we have the edge node or the point of presence where the mobile or multi-access computing proxies runs together with some distributed function, the core network, we have the metro, and then we have the central cloud, which hosts the 5G core network, control plane, and user plane. And then, of course, we have the end-to-end management system. What Huawei does to achieve an inbuilt security defense in-depth end-to-end security solution, it supports all standard security requirements. But more importantly, on top of that, it enhances the security controls by a specific and measures at different level in the network. So we do have mechanisms for equipment security, and we have specific security mechanisms to protect the radio access network, the MAC, the core network, slice security end-to-end, which includes slice isolation, encryption protection, and differentiated slice security, as well as we have mechanisms for mitigating, signaling, domain anti-denial of service attacks, and data domain anti-DDoS attacks. And on top of this, what Huawei provides is an end-to-end security management systems, which is consists of 2 levels of orchestration. So the first is a domain management system, which manage the security directly to the network element. And on top of it, we have a security operations center as an overarching system which enables an end-to-end security situational awareness, AI-based threat analysis and detection, for example, security orchestration, engine, and in particular, network element vulnerability management appropriately and in time. Right, so just to give an example of how those mechanisms are implemented for the 5G slice security. And you may see here that the Huawei solution, it is basically 3-fold. So on the one hand, we provide a solution that prevents unauthorized OEM access, especially targeting the exchange of interaction between the tenants and the network slice template. We then have controls to prevent data breaches across the end-to-end system. In particular, we have the support of mechanisms for slice access and also for secondary authentication for accessing the enterprise network. We also have a way to deploy differentiated keys so that we can prevent data theft and the key could be compromised. Then we encrypt the network slice selection assistant information for privacy preservation, and we have the possibility of introducing firewalls protection and network encryption between the public LAN mobile network and the external network where that particular communication, the vertical settings, terminates. We also have measures to prevent resource abuse, and here I'm thinking of virtual and physical resources isolation to preserve and prevent resource abuse and data breaches between distinct slices. That is done at the logical level, but also at the physical level. And in conclusion, what Huawei also provide, it is an end-to-end platform for implementing a risk mitigation framework end-to-end. We do have the possibility of deploying 3 distinct platforms in communication among themselves. So we have a security management platforms that will handle key certificates and identity management end-to-end. We then have a security analysis platform which collects data end-to-end and makes use of native security agents for real-time security situational awareness. So the native agents are deployed all over the network. So we have in the RAN on the back platform, as well as within the transport network layer and in the core network. And on top of it, we have a security control platform, which will allow us to set and deploy appropriate security policy and deliver all those scripts so that we can block threats and quickly recover in the case of anything happen into the end-to-end infrastructure. And the system works in a closed loop, so that the policy and the security is managed and improved depending on how the technology evolves, but also based on the logs and the signaling and traffic analysis that is made available to the security platform for then improving the security control mechanisms. Huawei has attained more than 270 security certificates, and in particular for the 5G, we have achieved certificates on common criteria that applies to the 5G RAN and OS. We have, as I mentioned, already passed the auditing tests for the 5G RAN and core, We also have a core network product line that won the BSIMMM Security Engineering in Maturity Model Level 2+, which basically pushed our organization rank on a top 5 in the industry. And we have also been tested the source code that applies to the 5G core network by an independent IT security service provider in Germany, and that basically demonstrated Huawei has established a mature and appropriate software engineering process. So I would like to conclude this talk by stressing the fact that the mobile industry does need a globally trusted, mutually recognized security assurance scheme. And our recommendations is to adopt and especially contribute to the NSAS scheme, because the NSAS scheme, it is really a customized, authoritative, unified, efficient, and constantly evolving security assurance scheme specifically for the mobile industry. So the industry players, the government and security agency and regulators are recommended to adopt the GSMA NAS for testing and evaluating telecoms equipment. And in particular, we believe that the NAS could be a part of a certification and accreditation process against a predetermined set of security standards and policies for security authorization in the country. So with that concludes my presentation. I thank you again for having me today, and goodbye.